Good morning, students. So today I am going to start the electromagnetism chapter. Okay. Basically, first I am going to discuss about the what do you mean by electromagnetism, and before going to that, I am going to discuss the magnetism. Afterwards, the effect of electromagnetism, and next Biot law, its applications, and later on the Ampere circuital law, all these things. Okay. So before going to start the magnetism purposes, so what do you mean by magnetism? Magnetism is nothing but the property of a particular substance. What kind of substance? The substance that is called the ferromagnet. So the ferromagnets who have this property of being attracted or being directive property or having the directive property, so that part is known as the ferromagnetic substance. And those the substances who are ferromagnetics, they are the main compound for the magnet. Okay, so therefore the magnet is the substance which have mainly two kinds of property. First one is the directive property, and the next one is the attractive property. Now the thing is that it is basic question. You all know that the repulsion is the best way or the most promising way to prove that whether a particular substance is magnet or not. Actually, for a particular magnet, when I am telling about a magnet, it always have two poles. It is bipolar. It cannot have a particular monopole, because each and every molecule of a particular ferromagnetic substance is itself a magnet, right? Suppose if I pictorially show you that a particular magnet or particular ferromagnetic substance is here. So suppose a magnet is here. So if it is the north pole and if it is the south pole, and suppose I break it from here, automatically here another south pole, here another north pole is going to produce. Now the thing is that why so? What is the thing which is basically making this kind of property? Again, if I break from here, again here south, here north is going to produce. Similarly, if I break through here, again north here and south pole is going to produce. Now what is the reason for this? The reason for this is basically the thing, each and every magnet basically is produced with some atomic magnet. That means whatever the atom that is present within this magnet, all this atom has this property of north south. Each and every atom has this particular north south pole. That's why basically whenever we are breaking some magnet, it automatically producing a bipole in both sides. Hopefully it is clear. Now the thing is that, so in this case basically, so this is the main thing for the magnet. That's why always dipole exists in a magnet and no monopole is there for a particular magnet. Okay. Now coming to that thing, that is, we all know that same pole repel each other and opposite pole attract each other. So therefore when coming for the magnet, so if north pole and south pole are together, they are being attracted for two magnets, and if two magnets have the same pole, then they are going to repel each other, right? So if I go for pictorially overview, if I get this or show you that another magnet is here. This is north pole, this is south pole. Another magnet is present here, who has basically, if north pole is there and south pole is there, so this north pole south pole is going to attract each other, and if it becomes south pole and if it becomes north pole, then they are going to repel each other, right? Now this repelling is said the more convenient way to prove that whether a particular substance is magnet or not. Okay, suppose I don't know whether this substance is magnet or not. Well, I don't know whether this substance is a magnet or not. Suppose it is an iron bar. Or else suppose I don't know whether it's iron bar or not. Now, and I know this is a particular magnet. Now, if this magnet attracts this substance, then two things can be there. What are the two things? First thing is that it may be a magnet and it is the north pole, that's why attraction is performed. Or else it is made up of iron, that's why it is being attracted by the magnet. These two things can be happen. But if these magnet repel this substance, then by for sure we can say that yes, it's a magnet and this pole is the south pole, because south pole is going to repel each other. That's why basically it is said that same pole repel each other, and repelling is the best way to say whether a particular object is magnet or not. Hopefully it's clear. Now coming to the concept of magnetic field. So what is magnetic field? If I consider a magnet here, suppose this is north pole, this is south pole. Now around this magnet there should be a particular region within which if I bring some ferromagnetic substance, suppose some iron particle or another magnet, then the attraction or repulsion is going to perform, right? So what I have said? I have just said that a particular magnet is there, and around that magnet a particular area exists where if I bring a particular magnet or a ferromagnetic substance, then only the attraction or repulsion occurs, right? So therefore, this region within which the magnet can have the capability to attract or repel something, or repel magnet or magnetic substance, then that particular region around that magnet is known as the magnetic field. So magnetic field is the particular region around the magnet on which it has the capability to attract or repel another magnet or magnetic substance. Now, what is the physical significance that this is the area, or how it is being produced? That is because of the magnetic lines of force, right? So, magnetic lines of force always starts from this north pole and ends here at the south pole. Always this circle is produced. Always. From north pole it exits, and at south pole it enters. Okay. So in this way basically, so at which amount of area, or at that amount of area where the magnetic lines of force exist, this is basically the magnetic field for this magnet. Okay. Hopefully it's clear to all. So in the next video, I am going to discuss some properties of these lines of magnetic lines of force and next Worsted experiment. Thank you.